Hi everybody, welcome to another MyTutor online school tutorial. Today GCSE Maths and we're looking at Trig Identities and Proof. Sounds very scary, but hopefully it will be a fun lesson. This session is 1 hour long, so it'll finish at 3 p.m. Here's me, Molly, I'll be running today's session. I'm just finishing my second year of Computer Science and Maths at the University of Bath, and I've done over 200 lessons with my tutor. So as I always say, hopefully that means I know what I'm doing. So if you haven't been to one of these before, I normally do, as I'll be doing today, a Kahoot at the beginning, kind of teach some stuff, we'll go through some questions together, same Kahoot at the end and see if the average score's gone up. So far it has every time, so hopefully that means I'm doing something right. Please do make great use of there's a Q&A and a chat function. So if you use those throughout to either put your answers on so that I know people are following, ask me questions, ask me to revisit an example, so on and so forth. So today is quite a tricky one, almost starts to venture into further maths territory, which is, terribly exciting. So bear with and kind of stick at it. Don't worry if you start feeling a bit stuck. I'm sure that you'll be able to do it. Oh my gosh, I did not know that there was a video playing in this. Getting tricky with it. Anyway, this is not my Kahoot, which is why there's a video playing in the background, but it is applicable. So here's the code. So get up your Kahoot app or go to kahoot.it and we'll do this Kahoot. Cool. So someone said, is what we're doing GCSE? Yes. And if it does venture into further maths, it's further maths GCSE stuff. But I think it is pretty much all on the harder end of just the GCSE spectrum. Yeah. I don't know why this video is playing in the background. I don't like it. But yeah, I found a Kahoot that was exactly what I wanted to go through. So I didn't think there was any point in me making my own. But it means that, yeah, there might be weird stuff like this. So I guess we'll see. Okay. Okay, so there are 32 of you here. So we've got almost everyone in the Kahoot. I know that not everyone joins, and that doesn't matter. You can just play along without actually putting your answers in. That's totally fine. So 6 more. This video in the background is so weird. Okay. I think is anyone still waiting? If not, I'll get started on it now. Someone says. Okay, I'll get started. I'll put this pin on the chat because I think you can join throughout. So don't worry if you haven't joined yet. So don't worry if you have absolutely no idea what's going on. If you don't know what cot means, if you don't know what this theta sign is, if you don't know how to do these, or as I said, what on earth is going on, either just leave the question or guess, and you will be able to do them by the end. Yeah, so well done if you actually knew how to do that. If not, well done to those 6 of you who guessed correctly. Someone said, is this trigonometry? Yeah, but it's kind of trigonometry without actually thinking about the triangles involved. It's just kind of theoretical. Yeah, this will make sense, I promise, throughout the lesson. Okay. Again, if you have no idea what this means, that's totally fine. Okay, cool. So again, a few people got that. I don't know whether that was guessing or whether you know how to work it out. Let me know actually on the chat. Do you guys know this stuff, or are these just guesses? Guesses. Okay. Okay, cool. If they are guesses, just like get them in quickly so that we can get straight onto the content of today's lesson. Well done to the two who got that one right. Okay, because no one's told me that they're not guessing, I'm going to skip after about 15 seconds. So get them in quickly, because there's no point in waiting for a minute for everybody to get them in. So this one I'll just. Okay, one person has said that they already know this stuff. So I'm just going to give this until this timer says 30. Someone said, is that the Mandelbrot set? Yeah, well then if you know if that is, that's, yeah. This is not linked to trigonometry or like this topic at all, this picture, but it is something called the Mandelbrot set, and there's some cool like advanced maths about that. But yeah, well then whoever knew what that actually was, cool. Okay, people got that, which is cool. Again, I don't know if it's because you knew it, probably not, but you know, well done. Okay, so I'm only going to let this timer go down to 40 this time. So get them in quickly, just because there are 11 questions and I don't want to waste your time. This one you might be able to get with what you already know, maybe not. Yeah, cool. A lot of people got that one. Well done. Again, I'm only going to let the timers go down to 40 on these. Cool. The guess, they don't seem to be too, it's normally more people getting them than not. So either the guesses are disproportionately skewed, or some people have seen these before. At least none of them have been 0 so far. Expression. Cool. Most people got the right answer there, whether by coincidence or not. If you have no idea what's going on, you know, you could do this column addition on the picture here. Two more questions left, so don't worry. And again, this one you might be able to do with what you know. And this is also the Mandelbrot set. You can, well, like versions of it, you can kind of see down here. I don't know. This one you're more likely to be able to get from what you know, but don't worry if you can't. Okay. Clearly not in that case, but that's all right. It's not like bad that you don't know this stuff. Like I said, it's really hard. Oh, we've got some numbers in there now. And this one, if you draw the graphs, you can think about it. I'll just let it go down to 30, just in case you want to have a think. Cool. Okay. So let's have a look at the podium. Let's see who's the best at guessing. Or they might know this topic. So 711 came third. Fredo came second. And in first, Star. So well then, you're either very good at guessing or you knew what was going on. Either way, that's good. So let's write down. To be honest, it's kind of best that people are guessing because it means that this isn't a pointless lesson. You know, if you all got 100%, then I'd kind of be wasting an hour of your time. So, right, 19% in total. Awesome. So we'll come back to that at the end. And for now, let's get into the lesson. So, first of all, you might not even know what a trig identity even means. So identity is this new kind of word that we'll be looking at. And what it means is just kind of two things that are exactly equal. So for example, an identity could be something like 1/2, and we write equals with 3 lines. And all it means is, I haven't done anything between these 2 steps. All it means is these 2 things are the 2 different ways of writing the same thing. So for example, 1/2 is equivalent to 2/4. We haven't really done anything. I guess you could say we've multiplied the top and the bottom by 2, but that doesn't really count. We haven't really done anything. It's an identity. These 2 are the same, exactly the same expression, 2 different ways of writing it. And that's called an identity. I've just chosen 1/2 as a random example for something. So it could be, we could say that 1/3 is equivalent to 2/6 or so on and so on. So the trig identities, and I'm going to give you a load. I've got them written down. I don't know these off by heart. I don't think you need to either. I think most of them will be in your formula booklets. So what I'm going to do is go through all of them. We're going to write them all on this one page, and then you can take a photo, take a screenshot, whatever, and then you have your little kind of summary of all the trig identities that you need to know. And then we'll go through some questions applying them. So let's get into it. So the first one, in fact, we're going to look at 2 to start with. The first one people may have heard of before. So the first one is, I need to make sure that I can fit these all in to the page. So I'm going to put them in like different sections. So these ones I'm going to call basic ones. And that is sine x over cos x equals tan x. I assume some of you have seen that one before, even if you haven't seen some of the other ones. And this basically means that if you have, say, sine 30, if we choose x is 30, sine 30 over cos 30 will give you the same thing that tan 30 does. Cool. So that's a really useful one, because if we see sine x over cos x in an expression, it means that we can simplify it to tan x. The second basic one is that sine squared x plus cos squared x equals 1. Now, when I write sine squared x, what I mean is sine x all squared. But we write it as sine squared x because if we wrote sine x squared, we might think that we were applying sine to x squared. So just think, when you see this, this is what it means. It means that we're taking sine x and squaring it. That's what that means. So when you take sine of something and square it, and cos of something and square it, and you add them together, you get 1. So that one's pretty cool, super useful one. And don't worry if you don't really understand what I mean at the moment. Once we get on to examples and kind of showing you how to apply these, it will make sense. I just want to kind of write them all down to start with, I guess. I'm actually going to put the headings in different colours so that you can differentiate it from what the thingies are. So these ones, as I said, these ones I'll call basic. We use these ones a lot and as parts. Then we have some, they're not inverse, what they called reciprocal. I think that's how you spell reciprocal. And what this means is 1 over. And we have 3 of these. So these are the things that you'll have been seeing on there. So we have Cos X or CSC. You'll either see it written CSC or Cos X. So I'll write it as CSC because that's how it is on the quiz. Cos X, all that means is 1 over sine X. And this is all a reciprocal, is it? So the reciprocal of 2 is a half, and the reciprocal of 3 is a third, and so on. It just means 1 over the thing. So the reciprocal of sine X, we just have this extra bit of notation just to write down what on earth it is. That's just because, I don't know, mathematicians are lazy and they don't want to write 1 over sine X every time. Because it comes up a lot, we've come up with a shorthand method for doing it. So that's that one. And then we have them for the other 2, trig identity, trig functions as well. Gosh, can't think of any words today. Then we have sec X, which is 1 over cos X, and cot X, which is 1 over tan X. So if you need a way of remembering which is which, this is what I do. The only one with a T in it goes with tan. And then I think that each one of these, each pair needs a C, or needs like a co in it. So cos, that already has a C in it, so it's got to go with sec. And by that I mean a C at the beginning. Sine, that doesn't have a co or a cos, so it's got to go with cosec. I don't know, that's how I think about it. Someone said, isn't cosec inverse sine? It's not inverse, it's the reciprocal. Because inverse sine, if you remember, is like the sine to the -1. So it's reciprocal. So these are the first 2 kind of bits. And none of these are too difficult. You might look at it at the moment because it's like, you're like, where are the numbers in that? I thought this was supposed to be maths. I get it. But I promise you that once we go on to questions, it will start making a lot of sense. So just stick with me with this one. So I'll keep these on here and we'll do some more. There's only a few more to go through. So there's now some that we use using those reciprocal ones. So I'll call them I don't know, let's call them reciprocal identities. Reciprocal identities. And these are just like those ones from the start. I mean, really what I should have done is what I said at the beginning and put equivalents instead of equals. They're the same thing. Don't get stressed about that notation. So these ones, so there's 1 plus tan squared x is equivalent to sec squared x. Again, that's just one that you have to know. There's no, you know, if you can't see where that comes from, that's fine. Neither can I. That's just a thing that you have to learn. Just trust that older mathematicians have proved that and that we can accept that as a fact. Same with 1 plus cot squared x is cos x squared x. So these 2, like I said, you've just got to know them, really. It's a shame. Someone said, what year do you learn this? That's a very good question. I think it's year 11. I think. But it was a while ago for me. So I'm not 100% sure. Okay, not many more to go, I promise. We're nearly there. Finally, we're going to look at some called the double angle formulae. So let's just draw a line under that because this is a slightly separate kind of thing. And we'll write them here. So the double angle formulae. Now these are used for stuff like to express, for example, sine of 2x in terms of just things with x's. And you'll see why that's really useful in a moment. But if you think about it, these only work when all of those x's are the same. So what if we had 2x, sine of 2x over cos x? We couldn't reduce that to anything. So what these formulae are used for are writing sine of 2x in terms of just things with an x rather than a 2x in it. Someone said, why are there so many of them? I agree. God, I wish there weren't so many. But they do come in really useful. And like I said, keep this as a cheat sheet when we, like once I finish writing at the double angle formulae, take a photo, screenshot it, keep it open next to this so that whilst we're doing questions, you can check back and look, because this, look at this, you know, don't try to memorize them. Like I said, I keep looking down because I have them here because I don't remember these, you know. Using them and learning how to use them is the important thing. Someone's asked, is this AQA? I did AQA and I did this, so yeah, I assume so. But it should cover all exam boards. I think all exam boards do this. Someone else said, will we need our calculator today? No, because we're just working with basically algebra of trigonometry. You won't need your calculator. Okay, I'll stop babbling on and actually tell you what the double angle formula are. So when we have sine 2x, that's 2 sine x cos x. So that means that we can write something that's a 2x in terms of smaller ones, which is really nice. Cos 2x, now that's equivalent to cos squared x minus sine squared x. And what we can do is, if we look here, because of this, well, cos squared x is also equivalent to 1 minus sine squared x, right? Just by a really simple rearrangement of this. So we could replace this with 1 minus sine squared x. And what we get is that this is also exactly equivalent to, by replacing either cos squared x or sine squared x, you get that it's cos squared x minus 1 or 1 minus 2 sine squared x. Have a look if you want to. Have a look if you want to, if you're, I don't know, watching this on YouTube afterwards. Pause it and see if you can derive those. So all you need is this, and you use this to substitute it in. If not, just memorize those, that's okay. Someone said, can you go a bit slower? I'm just going to write the last one down, and then I will slow down when I go through the examples. This bit is going to be horrible, and you're not going to understand until we start applying them. And then it will be much nicer, promise. Final one is just for tan 2x. And tan 2x is equivalent to 2 tan x over 1 minus tan squared x. Right, take a photo of this, screenshot this, save it, print it off, stick it on your wall, stick it on your fridge. I don't know, just these are, we like these. This page is, apologies for my not very neat writing. I'm in fact going to save a copy myself because save me having to write it out again if I ever need it. So yeah, this is your magic thing. You want this. Sorry, what's that second formula? Which one? I'm not sure which one you mean. Oh, do you mean this? My horrible 2 that looks like an L? That's a 2. I apologize for my writing. It's quite hard. It's neater in real life, I promise. Are there any other ones that people can't read? Okay, I don't think so. Oh, someone said I can't read the sec one. This one? I'll tell you what all of the ones that with second say. This says sec x equals 1 over cos x. And this says 1 plus tan squared x equals sec squared x. Right, now hopefully we're going to go through some questions and all of this will suddenly start to click into place. That's what we hope. So we're going to start with, we're going to do this one. Oh gosh, wrong tab. Sorry, don't mean to terrify you with university maths. I don't want to look at that. Right. Let's have a look at this one. So 2 sine x cos x is equivalent to 2 tan x. Sorry, 2 sine x cos x over 1 minus sine squared x. So the first thing that I would look at here is what can we do here? So we could make 2 sine x cos x if you all like keep your sheets in front of you. Oh, someone's asked to go back to this page to screenshot. Sure. Then we can spot things. For example, we could have rewritten 2 sine x cos x as sine 2x. But let's leave that for now because we want our final answer to be just in terms of x, not a 2x. So we'll leave that. So I was just seeing that maths, my heart just skipped a beat. Honestly, me too. The other thing that we can see here is this denominator. Let's think about whenever you see a 1 minus sine squared x or cos squared x, you should be happy because we can simplify that. Because if we think about one of our basic ones, sine squared x plus cos squared x equals 1, we can rearrange this. If we just subtract sine squared x from both sides, we get that cos squared x equals 1 minus sine squared x. So look at that. Our 1 minus sine squared x, we can rewrite as cos squared x. Now, when you get questions like these, it's always prove that the left-hand side is equal to the right-hand side. And the way that we do this is that we start on the left-hand side and you keep doing things and you'll eventually get what's on the right-hand side. So, for example, here we can now rewrite this as, so we write out our left-hand side. And we say that that can be written as the top divided by the bottom, which we can now write as cos squared x. So hopefully people can see that, how we have, rewritten just by rearranging one of our basic formulae, and you'll get really good at spotting these, honestly, like the more you do. Someone said, how do you tell which formula to use? Practice. Basically, once you've been doing it for a while, so what my brain did when I saw this was immediately go, oh, 1 minus sine squared x. I've seen that before, I know I can do something with that. And I promise that even by the end of this lesson, but especially once you've been practicing it for a while, you will start to spot these things because the same tricks and the same things come up all of the time. And you'll see that throughout today. So like I said, it's overwhelming for now, but hopefully it won't be. So now that we've got this, remember that this cos squared x is the same thing as just cos x times cos x. So we can cancel a cos from the top and from the bottom. So we get 2 sine x over cos x. You see that? Because this is just cos x times cos x, we cancel a cos from the top and the bottom. Hopefully everybody understands that one. Cool. Now, can anybody see what we can use here? Someone said, can you re-explain? Once we've got the final answer, I'll just go through back again step by step and tell you what we did. Yeah, perfect. Cassie has got that. Okay, so what we're going to use now is another of our basic ones from here, that sine x over cos x is equal to tan x. And this one you'll get really, really good at spotting as well. So if we've got 2 lots of sine x over cos x, that's going to be the same as 2 lots of tan x. And look at that, we've got what we wanted to get in the first place. And then what we do, and I showed you this the other day, draw a little box at the end, and that just means like the proof is finished, the proof is done, and it makes you feel really smart and cool. So recommend doing that. Okay, cool. So just to re-explain this one, as I said, don't worry if you don't get it, stay with me, we'll do more, and the more we do it, the more you'll get. So what we did was we started off by looking at this, and we saw that we could rewrite 1 minus sine squared x as cos squared x. And we can do that from this identity here, that we're just given, that's just a fact. And all we've done is rearrange it. So we've just taken sine squared x to the other side, we've just subtracted it from both sides, and see, oh look, we can 1 minus sine squared x is exactly the same as cos squared x. So why don't I just write that in place of it? It gets rid of this horrible 1 minus. We can just pop that in there. And then we see that cos over cos squared just gives us 1 cos. It's like if you had x over x squared, you'd write that as 1 over x. We're just cancelling a cos x from the top and the bottom. Then we've seen, using another of our identities, that sine over cos is equal to tan. So we've whacked that in there and we've ended up with exactly what we wanted. So if that even makes the tiniest amount of sense to you right now, you're doing fantastically. So don't worry, don't be disheartened if that didn't immediately click and you don't feel like Einstein yet. Don't worry. So let's have a go. Oh my God, that's the wrong thing again. I need to stop clicking on the wrong tabs. Let's have a go at this one because it uses similar things and it's hopefully a bit simpler to understand. Let's get the correct tab so that I don't give the students a heart attack. Right, there we go. Okay. So does anybody have any initial ideas about how we could do this one? Yeah, brilliant. 2 people have it already, which is fantastic. Yeah, in fact, 4 or 5 people, which is brilliant. Someone said, what does the A stand for? It's the same as if we had X. They basically just like throwing in other letters to confuse you. A really common one as well is theta. It's a Greek letter that we always use for angles. So up until this point, you're probably used to seeing X. So, saying that sine X, blah, 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 blah. Get used to seeing sine theta. Oh gosh, that was not a theta. Theta. It just kind of looks like a circle with a line and it looks like this. When you write it, it kind of looks a lot more like that. But I don't know, mathematicians are quite a big fan of using Greek letters because it makes them look smarter. So theta is always one that we use for angles. So yeah, don't be scared when you see that. It's just the same as X. Someone said, is this grade 9? Around there, it's probably grade 7 to 9 kind of stuff. And in an exam, you'd only get, I would assume, kind of one question like this, but it would be like a near the end hard question. Yeah, I think anyway. So yeah, anyway, back to this actual question. People have said exactly the right thing, so we can write the top. So you always start by writing out, this is how I always do it anyway. I say left-hand side equals and then write out what that is. And then we say, and that's equal to, and like people said, the top we can rewrite as sine squared A. And the reason is for exactly the same as here. But instead of subtracting sine squared x from both sides, we've subtracted cos squared x from both sides. So we can see that 1 minus cos squared x is sine squared x. So now you see how many of you spotted that time? So many more than last time, because once you've seen this kind of thing once, it's really easy to see it again. You kind of start to make the connections and see how it's similar to previous questions that you've done. Okay, someone said, can you at least tell if it's basic, reciprocal, or double angle? You can always tell that for yourself. So if it's going to be double angle, one of these would be a 2A. And if it's going to be reciprocal, you'd see sec, cosec, or cot on there. So we can tell immediately that it's going to be basic. So pretty much just refer to those 2 that you had before. So now that we've got sine squared A over cos squared A, we basically just write the last step. Because if sine over cos is tan, then sine squared over cos squared is tan squared. We just square each bit of the equation. LHS just stands for left-hand side. So this, like I said, from that identity, it's tan squared A. And then I always finish it off by saying which equals right-hand side. Because then what you can read is left-hand side, some maths, equals right-hand side. So that's what the proof is. So yeah, a couple of people I think are confused and finding that it's difficult. That's totally fine. This is a hard topic, but you're all smashing it. So well done. Okay, let's have a go at another one. Oh my gosh, if I could click the right thing. Let's have a go at I might have a go at one from here actually. Let's do this one. So this is actually quite a nice, easy one. Might not be easy to start with, so that's not to say that if you can't get it, you're not doing it right. But this, just in the sense that there's only really one step to it. So this is the theta. So prove that tan theta cos theta is equal to sine theta. So this, we're going to use one of our basic equations. Yeah, brilliant. Somebody's. Yeah, cool. So what we actually do here is, this is how I would write it. The basic principle of it is that we're going to use that sine over cos, and I should be writing thetas here, but sine over cos equals tan. And if you multiply it by cos, you see that sine equals tan times cos. But if we want to prove it in our proper, way that will make examiners love us, we say left-hand side equals tan theta cos theta. And then we just rewrite tan as sine over cos, which equals sine theta over cos theta times cos theta. And then you see here, we can cancel our coses out, and that's equal to sine theta, which is the right-hand side. And we're done. Someone said, will the examiner know if we write LHS? Yes, if you write LHS, they know that you mean left-hand side. That's quite a commonly used thing. So yeah, brilliant. Cool, well done, guys. Someone said, can we conclude it hence proved? Yeah, you can write anything you really want as required, hence result, it's proved, QED, you might have seen that one before. The box is just quick and examiners know what you mean because it's a widely used thing. Completely up to you. Okay, no, let's stick with these. These are quite good. Okay, let's have a look at, let's do this one. Right, so here we want to prove that sine theta minus sine theta cos squared theta is equal to sine cubed theta. Someone said, what does the box mean? Just means proof finished. I did it, basically. Anyone got any ideas for this one? How we might be able to do this here? So someone suggested dividing both sides by sine, which is a really, really good instinct. And that kind of could normally work. The thing is, when we're doing proofs, you have to just take the left-hand side and do, like, you can't just do stuff to both sides. It's really frustrating. But the way that you do it is you start with the left-hand side, do stuff to it, and you end up with what's on the right-hand side. So it's frustrating, but that's how you do it. Someone said, can you factorize the left-hand side? That's a fantastic idea of how we could start. And I guess it's kind of similar to the dividing by sine kind of thing that we had. So let's see. We can at least, we all know how to start it. We just write that the left-hand side is equal to whatever the left-hand side is. And that's equal to, yeah. So we factorize it. Take a sine theta out of both. What can we do now? Someone said, what's the highest you can get on this subject? I assume you mean like, what's the highest level? like this is pretty hard stuff here that we're doing is already really tricky. Yeah, perfect. Someone said, you know, put what is in the brackets as a sine squared theta. You see these same things coming up again and again. So this is then sine theta, lots of sine squared theta. And then what's sine times sine squared? Sine cubed. And that's what the right-hand side is. So we're done. And the good thing is that there are different ways to do this as well. You don't have to see that you can factorize it. In fact, the method that I did it when I was having a look myself was that I wrote cos squared theta as 1 minus sine squared theta, then expanded it out, and I still got the right thing. So, you know, there are different ways of doing it. You can, yeah, apply different things. So I need to start the quiz again soon in about 5 minutes time. So I'm going to move on to some with like cot, cosec and tan and stuff. So let's do, there any on here that have that? No. They are less common. This worksheet, by the way, is on Corbett Maths, which is a really good one to do. So let's find some. Trig. Here we go. Let's do this one. Someone's complaining that I've ditched Math Made Easy. Yeah, they didn't have enough good questions on this. I should write and complain. Okay, so now we want to prove that tan x sine x plus cos x is equal to sec x. So the first thing to remember is that we have to start with the left-hand side and work our way through to the right. But to make it easier for ourselves, we can imagine our sec x as 1 over cos x. So that's now what we know that we're working towards getting. So have a look at this and see if you can come up with a way to do this. I'll give it 30 seconds or so, and then I'll give you a hint and then give you some more time. I'm just making sure myself that I can do it. Always a good thing to do. Okay, so as a hint, what you should try to do is write tan x in terms of sine and cos, and then try combining the terms so that we just have one fraction. So I'll again give you a little bit longer and have a go at doing that and see what you get. Okay, so I'll go through it now. Now, the thing is, this took me a while to think about as well. This isn't the kind of thing that you just, if you're good at maths, you get it kind of thing. However, the reason that I can tell what to do is because of how many of these I've done before and how much I've practiced. So that's the best thing that I recommend. Get up some of these sheets, the Corbett Maths one, this one that I've just found here, which is on this link. I'll put the link actually to this on the chat because this looks like a really good website. Because the thing is, the more you practice, the more that you can actually spot these kind of things. So the reason that I turned tan into sine over cos was because I could tell that I don't want a tan involved at all in this. So we're going to say sine x over cos x times sine x. Oh, I forgot to do the whole left-hand side equals thing, but imagine that I did that, plus cos x. So all I've done is I've rewritten tan x as sine x over cos x. And then we can see here that this becomes, so I'm going to do two things in one. I'm going to multiply and just make this one fraction, so it's just going to become sine squared x over cos x, just multiplying that fraction in. And then because we want to combine the fractions, and this is something that you'll probably do a lot, we want to write cos x as something over cos x, because then we can actually add these fractions together. So if we write it as cos squared x over cos x, so I'll explain why I did that. We want it to be, we want cos x as the denominator because we want to be able to add them, and you can only add things when they have the same denominator. But we also wanted it to equal cos x so that the equation doesn't change. So we're going to write cos squared x over cos x. Then we can add these fractions just like we would always add fractions. So sine squared x plus cos squared x over cos x. Now we have an identity that sine squared x plus cos squared x is 1. So this becomes 1 over cos x, which we know is sec x. And we're done. So that's a difficult one, but hopefully you can see that the steps that I've worked through, they all make sense. They're all logical. There's nothing there that you can't do. So what we're going to do now is we're going to do the Kahoot again. And after each question, once we've got the results in, I'll work through it and actually tell you how the answer was gotten. So we're doing more, we're doing more examples as we're going through it, as well as testing our understanding. So let's play it again. So I think some people, so here's, I think it's the same game pin as before. So some people are already in it if you've kept it open, but just join now if you haven't. So I think, oh, is this going to keep it with, oh yeah, it's kept some people from before who have, I might have to make a new one because it's, I'm going to do that actually, make a new one with it. Yeah, I'll do that. Just because that was going weird. I thought that it would be quicker if I just clicked play again, but apparently not. There you go. Okay, join this one now. And I'll pop, so that second one that I sent, that's the actual code now. Cool, joining. This video is really very strange. Rice King. Okay, so there are 38 of you here, so I'll wait till there's, I don't know, at least 30 in here. Anyone else getting really into this video? Okay, Is anybody still waiting? If not, I'll get started. Okay, I don't think anybody's waiting, so we'll go ahead and get started. I've put the game pin on the chat though, so that you can join whenever, and it's also down there. Okay, so cot theta sec theta. So try rewriting that as 1 over tan theta, 1 over cos theta. What do you think that becomes? So you'll only really need one of those basic identities for this. I'll skip to the end. Sorry if you didn't get a chance to get it in. Yes, loads of people. Yeah. So the way that we do this is we write 1 over tan theta times 1 over cos theta. Multiply them together, we're going to get 1 over sine theta. And that's because sine over cos is tan, so sine is cos times tan. So you get 1 over sine theta, which is cosec theta. Okay. So we're going to get an expression. There's a picture. Say what that's equivalent to. I'm going to skip nearer the end. So get your answers in as quick as you can, just so that I don't run over. Okay, I'll skip there. Brilliant. The majority again got it. So what we had to do here was write sec theta as 1 over cos theta. And then you'll see that this becomes 1 over cos theta tan theta, or 1 over sine theta, which is cosec theta. So what about this one here? We have tan theta over sec theta. So think about what sec theta is, rewrite that. And you might need to use your rules about dividing fractions, so keep, change, flip. Okay, I think most people have got in, so I'll skip. Cool, at least the majority got that. That's fantastic. So what you do for this one is you rewrite sec theta as 1 over cos theta. And then you've got tan theta divided by 1 over cos. That's the same thing as tan theta times cos theta, which we've just learned is sine theta. So this is cosec theta times tan, I'm trying to work out, cosec theta times tan theta times cos theta. So lots of things to think about, but just work with what you know. Some people have said that they're still guessing. That's totally fine. You know, 1 hour isn't always enough for some people. So maybe just have a watch back of the video and have a go at some of the sheets that I've gone through. And then you can always come back and watch the video, watch the quiz and see if you can get them. I'd really recommend doing that if you don't always follow. Brilliant. Well done, guys. Fantastic. So don't need the media for that one. So the way that you do this is that you write cosec as 1 over sine theta. And then you've got 1 over sine theta times sine theta over cos theta times cos theta. And when you multiply that out, it cancels down to 1, which is fantastic. Okay, halfway through. I'm really going to have to speed them up now so that I finish on time. That huge dot means multiplied by. So this is sine times cos over tan. Also, they've got x's in the question and then theta's down there. Just assume that they're the same thing. Cool. Okay, yeah, this one's a bit harder. I can see why, but still most people got it. So the way that we do this is that we write tan x as sine over cos. And then using keep change flip, we get sine times cos over sine. And again, when you cancel that all down, we get cos squared. Sorry, my explanations are a bit quick, but hopefully they make enough sense. And if you watch it back, slow it down, write down what I'm saying, it will make sense. So I think this is an easier one. Look at that cheat sheet that I gave you at the beginning and think about what we can replace here. Brilliant, lots of people got it, that's fantastic. So the reason is we've got an identity that just tells us that sine squared plus cos squared is 1. So this is 1 over sine x, which by definition is cos x. So all that is looking at the cheat sheet and literally just blindly applying stuff. Okay, let's have a look at the next one. This one's quite difficult. What I would advise doing here is writing them as trying to put them over the same denominator. Oh, the majority still got that. That's fantastic. I don't really have time to fully explain this one, but if you multiply the left one by 1 plus cos A and the right one by 1 minus cos A, and then add the fractions together, you should get it. Almost there. Well done. So with this one, if you rewrite the top as cos squared A and divide through, you'll get that. I know we're running over a tiny bit. Don't worry, I've got a joke ready. So sec squared x plus cos x squared x. A bit harder now. I think the best way to do this is to write them as 1 over cos squared and 1 over sine. Maybe not. Ah, yeah, it is. Well done. Yeah, so if you, wrong thing, up here, if you write them as 1 over sine and 1 over cos and try to get them over sine squared theta, cos squared theta, you'll get that the top is 1, the numerator. 2 more left. Stay with me, almost there. This one, expand it out. Just expand out those brackets using FOIL method or whatever else you use. Give it a go, see what you get. Sorry if some people didn't have enough time. Well done though. So if you multiply out, you get 1 minus cos squared theta, which we've learned is sine squared theta. Last one. Now this I didn't actually go through, so I'll go through it now. But just draw the graphs of sine and cos and have a look. Okay, sorry if I haven't given you enough time. Oh, well done though. Lots of people got that. So the way that you think about it is that this is the graph of sine theta. And if you remember from our transformations lesson, actually, adding 90 degrees shifts it back 90 degrees. So we shift it back and we get this, which is the cos theta graph. So that's how that one is done. Right, done. Let's see. Oh, look at that. Third place got 10 out of 11. Perfect. Well done, COVID. Oh man, and the top two got all of them right. Fantastic. Rice King, nice. Well done. Absolutely smashed it, guys. And Emma and Louise in 4th and 5th row as well. That's fantastic. So let's have a look. So at the beginning of the lesson, it was 19%. Now it's 41. Yeah, huge improvement. Massive improvement. So well done, everybody. Sorry I overran a little bit, but well done for sticking with me. I hope that makes more sense. Do check out the MyTutor website for more tutorials coming up. I'll personally see you tomorrow, I believe. No, day after. Tomorrow is my birthday. Woo! There is a maths joke, don't worry. So I'll see you on Thursday. MyTutor also offers one-to-one tutoring, so that's a really good thing to check out because that helps a lot more than these often do. And to finish on a maths joke for today, why did I divide sine by tan? Just cause. And if you've paid attention today, you'll know that sine divided by tan is cos. So cool. Thank you all for coming. Have a great week, and I'll see you on Thursday. Bye.